Good morning. Hope all is well. I want to get a poll question out of the way. Some of you I was emailing or writing on Google Classroom about an optional game day Friday on Thursday this week. So let me know if you're interested because I don't want to create more work for you, but I also don't want to not see you a second time this week. It would just be games, I promise. Anyway, especially now that I have screen sharing capabilities back in full effect where I was struggling a week or two ago. So the French version of Countdown is definitely in the mix for our game day Thursday if we play. Anyway, I want to talk about what your topic is for today, which is surface area of pyramids. And there's different type of pyramids. This is called a triangular pyramid. You'll see triangles in every single type of pyramid, but some have a triangular base, some have a square or rectangle base. In fact, some have pentagonal or hexagonal bases, but we're not going to go there just yet. When you see a problem like this, I want to go directly into IXL to help you out with how I envision you doing these type of problems. Whenever I do this type of problem, and hopefully this isn't backwards on the screen. No, it looks like it's going to be fine. Whenever I see a three-dimensional drawing or a 2D drawing of a 3D figure, you know what I mean? Because on two-dimensional paper or screen, it's not really three-dimensional. It's just giving the illusion of three dimensions. But what I do is I give myself a little bit of a roadmap as to what the structure consists of, meaning I need to figure out surface area. So I'm doing the total area of each and every face. So I come up here and I say, oh, there's just one triangle, there's one base that has a base, another one where there's words that mean different things, right? There's a base of the, this is called a tetrahedron, triangular pyramid is fine. This is the base of the pyramid. These are three additional faces, although the base is also one of the four faces. But anyway, to get the total area, I have to break it down into parts as to finding the area of each face. So when I see this, I say to myself, oh, I'm going to write it. It's 1/2 times base times height, the base and height of the triangle, not the overall triangular pyramid. So that I hope you see is 1/2 times 6 times 5.2. I don't want to use a calculator. I'm going to look for, I wrote it 6 before the 5.2 because I know that's 3, right? 1/2 times 6 is 3. 3 times 5.2, 15.6. All right, let's go down here. Before I write it down, you might want to pause. In what order should I write it so you don't have crazy calculations? Well, I'm going to say again, take care of that 6. 1/2 times 6 times 9, right? 3 times 9 is 27, but there was only one face up here, but there's 3 of these type of faces, so it's 27 times 3. Maybe you think of it as 30 times 3 minus 3 times 3. Maybe you just do 27 times 3 in your head, or you write it down, and you should get 81. Now we have to add them all up to get 96.6. And IXL lets you get away with not writing your units of measure. It's like there for you on the screen already. But I want to make sure you get in the habit of writing 96.6 centimeters squared. So really, before I enter it in to see if I got it right and get embarrassed if I got it wrong, is no harm in getting something wrong, especially in IXL. Come on, be okay getting something wrong. Come on. But before I put it into IXL, I want you to know centimeters squared, square centimeters, and the roadmap of drawing what faces there are and how many of each one there are as well. So we can type it in. Let's see, 96.6. Give me that green check mark, please. Excellent. Let's go. Okay, we're not going to do the next one. We are going to go to learn by an example, um, which hopefully I can get you back to pretty easily. So I want to make sure you're using the example. So look at this before you go. The learn by an example feature is here. I know some people haven't been able to find it, and it'll give you a roadmap. It's funny because it gives you a different example each time, so you might want to keep on clicking on it. When I checked Learn with an example before, they showed a square-based pyramid, which just means that you'd be finding the area of one square base instead of one triangle, and then four different triangles as opposed to three triangles. And then if it's square, those four triangles are all going to be congruent. They're all going to be the same. But if it was rectangular based with different sides, then you're going to have two triangles of the same area and another two triangles of a different area. So I want you to really like play around with it and give the roadmap. You don't have to draw each one separately. You might want to draw this one and then say times 3 like I did on the dry erase board. But I know you've been doing a great job playing around with it, so that's what you'll do. The last thing I want to say is most of you did the full assignment yesterday by doing both volume and surface area of the cones. If you didn't, if you missed in the instruction that you were supposed to get the surface area of the cones, and in terms of pi, please make sure you do that and you can resubmit the assignment on the post for today so I don't have to like miss it. If you didn't do surface area, please include it. And thank you to those who not only reached out to me, but also looked on their own to find videos that would help them in figuring out surface area because you did have to use Pythagorean theorem. So I'm going to attach also a video that one of your classmates found on her own, and I think it'll help you as well if you haven't done the surface area portion of your cones work yesterday. So today, if you finished yesterday's work, today's assignment is going to be an IXL link. And to get back to me in the comments section on whether or not you want the optional game day Thursday, because we'll figure out a time in the schedule. All right. I keep on saying last thing and then I say one more thing. The last thing is please continue, if you've been doing it, to reach out to me. I can do impromptu Zooms if you have any questions, you want to chat, you want to challenge. It doesn't have to be just for help on the given assignment. All right. Have a good day. Look forward to seeing you tomorrow.